Okay, here we are. We're going to go over the trig review. I hope this video helps you guys. I feel a little weird because you can see me. Normally when I video, you can't. And I'm at home on a Sunday morning, so just bear with me. We are going to start with this study guide. And I emailed it to you. This study guide has a corrected part to it. And I'm just going to go through each problem. I'm going to try to do it here on this little whiteboard. I know there's some reflection going on. We might try to get those. Okay, I'm going to go ahead and start with the first one. The first problem says classify the angle as acute, right, or obtuse. And it's a, get this so y'all can see a little bit more of this screen, this board I'm working on here. It's a 91-degree angle, and we all know that that is obtuse. Okay, so I don't think that you have any trouble there. The second one is pi over 2. You have two options here. One option is to use your unit circle. Pi over 2, you see right there, is 90 degrees. The other option is to change that to degrees. So you could multiply it by 180 over pi. When you do that, pi's cancel. 180 over pi is 90. So this is a right angle. And why on earth I would have put straight angle on that one, I have no idea. So make sure you know that number 2 is right. It's D, right angle. The next one says find the radian measure for a central angle, and that tells me that R is 5 inches and S is 25 inches, and they want us to use the formula S equals R theta. So I'm going to plug in, and S is 25, R is 5, and to find theta, there's still a reflection on there. I'm going to work on that reflection. I'm going. So I've got trying to get some of these reflections out of here. So we have 25 equals 5 times theta. Let me turn this around just a second. I'm at home on a Sunday morning. My children are acting just exactly like you'd expect them to. Wouldn't change them for the world. So theta turns out to be 5. So for that problem, and that is problem number 3, the answer is B, 5 radians. Number 4 asks you to convert the angle from degrees to radians, and it's 160 degrees. And what you need to do is you're going to multiply by pi over 180. If you're trying to get rid of degrees, multiply by this ratio with the degrees on the bottom. Back up here in number 2, we were trying to get rid of pi, so we multiplied by that ratio. It's reciprocal with 180 over the pi, so these things will go away. So what we do here is we have, that simplifies. 20 goes in here 8 times, 20 goes in here 9 times. So this turns out to be 8 pi over 9, and that's radians, and that is answer choice A. I'm now on problem number 5. It says convert from radians to degrees. So number 5, they have negative 34 over 9 pi, and they want you to convert that to degrees. So we're going to multiply by 180 over pi. Trying to get the pi's to cancel. That's what they'll do. I'm going to put that in my calculator. Negative 34 times 180 divided by 9 gives me negative 680. Negative 680, which is answer choice C on the handout. Number 6. Number 6 says find the positive angle less than 360 or 2 pi that is coterminal with the given angle. Okay, the angle they give you is 673 degrees. You want to know how many complete trips around the circle you can make. You can go around one time, you've used up 360. So 673 minus 360 means that how much further do I have to go? 673 minus 360 is 313 degrees. That's less than one full trip around the circle, so you're going to go another 313 degrees. So the coterminal angle would be the one that started here and went there 313 degrees, and that's answer choice C. Number 7, find the length of the arc on the circle intercepted by the central angle theta. It's the same formula we used earlier, S equals R theta, and they tell you that R is 35, and they tell you that theta is 25 degrees, but they want theta to be in radians. So you've got to take 25 degrees and multiply by pi over 180 to convert that to radians. And when you do that, you can put that in your calculator and you can have a decimal value. 25 times pi, use the pi button on your calculator, divided by 180, I get 43633. I'm going to multiply that by 25, and for that one, no, 35, multiply it by 35. My answer here, you can't read that, that looks terrible, but what I got in here was 0.43633, and it kept going, and this turned out to be 15.27. So number 7, that answer is C. Number 8, find the sine. Okay, they've drawn us a triangle. They've given you 2, 5. Theta is here. They tell you 2 and 5, so you got to figure out the hypotenuse. So you want to do 2 squared plus 5 squared is c squared. This is 4. This is 25. Turns out to be 29. So it's the square root of 29. That is your hypotenuse. And the sine of theta, if you're sitting at theta, I always put smiley there and say, okay, this is my opposite. This is my hypotenuse. So it's 2 over the square root of 29. Let me pause. So we're looking for sine, and sine's going to be opposite over hypotenuse. So it's going to be 2 over the square root of 29. But you cannot leave a radical in the bottom. So you're going to have to multiply by the square root of 29 over the square root of 29. And you're going to have 2 square roots of 29 over 29 for your answer. And that is answer choice C. And again, that's problem 8. Okay, problem 9, they give you a triangle. And we have 4, 5. When we do the same process we did on number 8, we're going to square 4 and square 5. We're going to get 16 and 25 is 41, and then I'm going to need the square root. That's the square root of 41. They're asking me to find the cosine of theta, and they put theta over here at angle A. So I'm going to need the adjacent and the hypotenuse. So the cosine of theta is 5 over the square root of 41. Can't leave a radical in the bottom, so I'm going to multiply by the square root of 41 over the square root of 41. It's going to give me 5 square roots of 41 over 41. This is answer choice C for number 9. Number 10, very similar to 9, and we're going to have a leg that's 9, a leg that's 7. So 9 squared plus 7 squared is c squared. 81 plus 49 is c squared. Let's see, what's that going to be when I add that up? 130. 130 is c squared. So this is the square root of 130. Let me see. Can we simplify that? Let me see just a second about 130. And we're looking for the tangent and what angle of theta. Oh my goodness, we didn't even need the hypotenuse. All we need is opposite over adjacent. 9/7 is the tangent. 9/7 is the tangent of theta. That's answer choice number A. Okay, we're on number 11. And number 11, they give us two right triangles. It says, use the given triangles to evaluate the expression. Rationalize all denominators. So they want the cosecant of 45 degrees. The cosecant of 45 degrees. And they give you this 45, 45, 90. And it's 1, 1 and the square root of 2. And what I need to know is that the cosecant, if the cosecant is the hypotenuse over the opposite, because it's the reciprocal of the sine. So, where am I at? 45 degrees is right here. So here's smiley. Here's the opposite. Here's the hypotenuse. So the cosecant here of 45 degrees is equal to the square root of 2 over 1, which you can just write as the square root of 2, and that is answer choice D. Number 12 asks you to find the cotangent of pi over 3. If you don't know what pi over 3 is in degrees, you have two options. You can multiply by 180 over pi, or you could use your unit circle, but that's going to be 60 degrees, what we're going to get when we do that. So then that 30, 60, 90 triangle that they drew, they put the 60 degree here, put the 30 here, this is the square root of 3, this is 1, and this is 2. So if you're sitting here and you want the cotangent, well, the cotangent is the reciprocal of the tangent. The tangent is the opposite over the adjacent. So this is the adjacent over the opposite. So if I'm sitting here, this is my adjacent and this is my opposite. So it's 1 over the square root of 3. I can't leave it like that. I have to multiply by the square root of 3 over the square root of 3, which gives me the square root of 3 over 3 for number 12, and that is A. Number 13. Number 13 tells you that the sine of theta is 3 over 7, and that the cosine is 2 square roots of 10 over 7. Now this is what that tells me. When I look at that, I know that sine is opposite over hypotenuse, but I also know that it's y over r, and cosine is x over r. So I know that y is 3, x is 2 square roots of 10, and r is 7. And I can use those values to make any of the 6 trig functions that they ask for. And what they're asking for here is the cosecant of theta. And the cosecant is the reciprocal of the sine, so it's going to be 7 over 3. And that's answer choice A. And again, I'm working on problem 13. 14 says sine squared of 55 plus cosine squared of 55. Okay, 14. Sine squared of 55 degrees plus cosine squared of 55 degrees. Use an identity to find the value of the expression. Let me find the identity sheets that are laying here. On this identity sheet, here's your identity sheet. Okay. I'm looking at the one that has something to do with sine squared. And I see it at the very top. It says Pythagorean identities right here. And it says sine squared of x plus cosine squared of x equals 1. What that means is any angle you have, if you take the sine squared of that angle and the cosine squared of that angle and you add it together, you're going to get 1. So number 14, the answer is A, 1. Number 15 says find a cofunction with the same value as the given function, and they give me sine of 54 degrees. On your sheet, we ought to have cofunctions on here. Is it on here? Let me find it. Sum of the product, sum, reciprocal, double angle, reducing. Okay, I don't see them on there. So here's what it says. I'm going to tell it to you. And if you need to, you're probably going to have to just memorize this. The sine of an angle say alpha, is equal to the cosine of 90 minus that angle. So the sine of 54 is equal to the cosine of 90 minus 54. And 90 minus 54 is 36. So this is the cosine of 36 degrees on number 15. That is answer choice C. Okay, number 16 asks us to find the secant of 60 degrees. Well, the secant is the reciprocal of the cosine. So I know that the cosine is x over r, or it is adjacent over hypotenuse. So the secant is going to be hypotenuse over adjacent. So here I am at 60 degrees, and if I'm sitting here, this is my adjacent, and this is my hypotenuse. So I want the hypotenuse, which is 2, over the adjacent, which is 1. So that's going to be answer choice C for number 16. Number 17 says use a calculator to approximate. Be sure that you put your calculator in the right mode. If you're in degrees, be sure it's in degree mode. If you're in radians, be sure it's in radian mode. You just put that in your calculator, and the tangent of 58 degrees is 1.60, which is A. 18, find the measure of the side of the right triangle whose length is designated by the lowercase letter. Round your answer to the nearest whole number. Okay, we're looking for A. They tell me that this side is 13 and this is a 31 degree angle. So I'm going to put my little person here. Here's my perspective. I'm looking here. This is the opposite side, and this is the adjacent side. So I know that I'm using tangent. Tangent of 31 degrees is equal to A over 13. So I've set up my problem. Now what I need to do is I need to get on my calculator, make sure it's in degree mode, and I'm going to multiply by 13 on each side, and I'm going to type in 13 times the tangent of 31 degrees, and that answer is, round to the nearest whole number, 8, and we're in centimeters, so this is answer choice A. Okay, I'm on number 19 now, and this is page 4 of the handout, and it says 1 plus sine squared of 25 plus sine squared of 65, and find the exact value of the expression. Do not use a calculator. Well, here's what they're wanting you to do. They're wanting you to change. You see this 65 and this is 25. It's not the same angle, so I can't say that that's equal to 1. What I have to do is I have to transfer this one over and say that the sine squared of 65 is equal to the cosine squared of 90 minus 65. Well, that's going to be the cosine squared of 25. That's what I need, because I need to be the same angle and I need it to be the cosine. So this goes in place of that. So it says 1 plus sine squared 25 plus cosine squared 25. Now remember from your Pythagorean identities that that part's equal to 1, and 1 plus 1 is 2, and answer choice D is what I need for 19. Number 20 says use a reference angle to find the exact value of the expression. Number 20 is the cosecant of 3 pi over 2. Where's 3 pi over 2 located on the unit circle? Okay, the cosecant of 3 pi over 2. Kind of backtrack so I'd have a little more room. Use your reference angle. Well, where is 3 pi over 2? 3 pi over 2, this is 0 pi. This is 1 pi. This is 3 pi over 2. You're right down here. So you'll want to pull out your unit circle, okay? And what you're looking for there is the cosecant, and the cosecant deals with r over y, and at that point, r is always 1, y is negative 1. So that answer is negative 1, which is B. 21 says use a reference angle for the given angle, and it's 9 pi over 8. 9 pi over 8. Well, 9 pi over 8. Here's what I think of. I think of the unit circle, and I think this is 0, and this is 1 pi. So this would be 8 over 8 pi. If that's 1 pi, that's equal to 8 over 8 pi. Well, 9 pi over 8 would be a little bit past that. How much past that? 1/8 pi past that. That's the reference angle. It's 1/8 pi, which is pi over 8, which is B. Okay, I'm gonna talk about 21 again. I think I might have mistakenly not hit record when I was doing it. 9 pi over 8 is a little more than 8 pi over 8. And 8 pi over 8 is 1, and that's where it happens at, is over here at 180. So you need to go a little past that. 1/8 of pi. So that reference angle is pi over 8. Okay, we're on 22. And it says the point xy on the unit circle that corresponds to real numbers is given. Find the value of the indicated trig function. And they give me 5, 6, and square root of 11 over 6. This is your x value. This is your y value. And they want the tangent. And the tangent is going to be y over x. So it's going to be the square root of 11 over 6 over 5 over 6. So you're really doing the square root of 11 over 6 divided by, which means multiply by the reciprocal, 6 over 5. And you're going to cancel here, and you're going to get the square root of 11 over 5, which is D. This was one of the ones I mistakenly put the wrong answer on. C is not right. D is the right answer on that one. Okay, number 23. Number 23 says find the amplitude of y equals 3 times the sine of x. We know the amplitude is right there, so the answer for this one is B, 3. 24 says find the period. They want you to take 2 pi and divide it by b. Well, b is the coefficient of x. So in this problem, it's 1. So 2 pi over 1 is 2 pi, and that answer is D. 25 says what is the amplitude? And this is a -2, but amplitude, I should have said up here, it's actually the absolute value of whatever's right there. So that's going to be 2, and that's answer choice A. 26 asks us to find the period of y equals sine 3x. And so to find the period, it's 2 pi over b. B in this case is 3, so it's 2 pi over 3. Answer choice B. 27 asks us to graph this function. I'll show this to you here. I'm trying to get it where you can see it. Can't see it very good. There we go. And the function is y equals 2 times the sine of 2x. We know that the amplitude is 2. So we know that this graph, whichever one we choose, needs to be 2 tall. So let's see about the first one. The first one is that tall, the second one's that tall, the third one's that tall, and the fourth. So all of them are having an amplitude of 2. The period is 2 pi over 2, that 2 that's right there. So the period is 1 pi. So it needs to go through all of its values in the space of pi. Well, the first one they show you, by the time you get from 0 to pi, you hadn't even gone through a quarter of them, so that's not it. The next one, it's the cosine function instead of the sine function. That's not it. It doesn't start at the right place. C's got to go through 0, 0, and then it's got to go through all of its values by the time it gets back to pi. So C's the right one. D's wrong because it doesn't have the right period. So on 27, the answer is C. 28 says determine the phase shift, and the function says y equals 2 times the sine of 2x minus pi over 3. To find the phase shift, we are going to take 2x minus pi over 3 and set it equal to 0. So we're going to add pi over 3 to both sides. So it's going to say 2x is equal to pi over, that's a 2. I can't see very well in here today. That's a 2. Sorry, guys. Going back and making the corrections. Then you're going to multiply both sides by 1/2 to get rid of that 2. So x is equal to pi over 4. This is your phase shift. Since it's positive, it means it's going to the right, and the answer choice for 28 is C. Okay, 29 says find the amplitude. So there again, you're taking the absolute value of that number. So that amplitude is 5. So answer A. Number 30 asks us for phase shift again. So I'm going to take 1/2 x minus pi over 2, set it equal to 0. When I add pi over 2 to both sides, I'm going to have 1/2 x is equal to pi over 2. I'm going to multiply by 2 to get the x all alone. When I do that on this side, I'm going to end up with pi. So it's pi units to the right because it's positive, and that is answer choice A. 31 says find the exact value of the expression, and they want you to find the sine inverse. So they're asking sine inverse of 0.5. What they mean is, what angle has a sine of 1/2? So 1/2 has the corresponds on, you can use your unit circle. Where is y 1/2? Well, y is 1/2 here at pi over 6, and again over here at, let's see, y 5 pi over 6. So look at your answer choices. 5 pi over 6 is not an answer choice, so C is the answer. So it's pi over 6. Cosine inverse of square root of 3 over 2. They want to know wherever cosine is the square root of 3 over 2. They're wanting to know on here, where is cosine? Cosine deals with x. So where is your x value? Not negative. Where is your x value? The square root of 3 over 2. So I look, and it's at pi over 6. And again, it's at pi over 6 here. And it's again at 11 pi over 6. So look at my answer choices. And both of those are on there. So which answer do I choose? Find the exact value for C. Actually, let me look really close. They're not restricting our quadrants. I'm going to take B or C on that one. B or C. I'm going to look back at that problem. 33, tan inverse of 0.9. You're going to put that in your calculator. I didn't even put an answer on the study guide for that. Second tangent of 0.9. Let me put my calculator in. It's in radians. So what is that? I get 0.73, which is C. Okay. I hope you do good on the midterm. I don't think it's hard. I think it's lots easier than what you were doing in Chapter 2. Please keep in touch with me over Chapter 3. It is going to be difficult. You'll probably want to Zoom, or we'll probably need to do another video or something. Give me feedback. Let me know what you need so